So it says the remainder theorem says if a polynomial, p of x, that's just the name of a polynomial, so any polynomial, is divided by some binomial, x plus or minus a, okay, like we were doing the other day, then the remainder, then the remainder is actually the value of your function when x equals that a value. You remember how we were doing this on synthetic division the other day? We took this binomial, we set it equal to 0, and we solved it for x. So if I were to do that, if you did x minus a equals 0, and you solved it for x, then x would equal a. What this is saying is your remainder is going to be the same thing as just plugging in the value of the number into the function. Okay, so I'm going to show you 2 ways to do it. You can choose which way. Some people like to plug it in more than they like to do synthetic division. Okay, so we're going to find p of 2. We're going to find the value of our polynomial p when x is equal to 2. And there are 2 methods, like I told you. We're going to substitute that number in for x, which is what we're going to do first. That polynomial is 4x to the 5th minus 3x to the 4th plus 2x to the 3rd minus 7x squared plus 9x minus 5. Pretty long polynomial. And what we want to do is we want to substitute in 2 everywhere there is an x. Okay, so the number that's inside your parenthesis here, that 2 right there, is what we're going to put in place of x. Everywhere there's an x, I'm putting a 2. And then we would have to simplify that out, which means we would have to go through and do all of our exponents first before we do any multiplying. So that 4 is going to stay. I need to do 2 to the 5th power. What's 2 to the 5th power? $32. Okay. Minus 3 times, then we're going to do 2 to the 4th power. 16. Okay. Plus 2 times 2 to the 3rd power. 8. Minus 7 times 2 squared, which is 4. Okay, and then the rest of it doesn't have exponents. Everybody understand this so far? Okay. All right, then we need to go through and do all of our multiplying. So we're going to do 4 times 32, which is 128. 3 times 16 is 48. 2 times 8 is 16. 7 times 4 is 28. 9 times 2 is 18. Minus 5. Now we can just do the rest of it in the calculator. 128 minus 48 plus 16 minus 28 plus 18 minus 5. And what do we get? 81. Okay. So that's the value of the polynomial when x is equal to 2. That's your first option. Okay. Anytime it has your p or whatever the name of your function is, if it's f, it'll be f. But whatever number's in the parentheses, you can substitute that in for x and you can find the value of that polynomial. Everybody good with that? Or we can use synthetic division. I'm going to do it right here so I can actually see my function. Well, God, let me write this down real quick. So we're finding p of 2. I'm just rewriting everything. So I can slide it down and have some room to work. Okay, so if we're going to do synthetic division, Then what we do is the number that's in the parenthesis is the number that goes in our box. And then remember, I use my coefficients. I have to start with the highest degree to x and go down from there. Am I missing any terms here? I have x to the fourth, x to the fifth, fourth, third, second, and first, right? And a constant. So the coefficient of my x to the fifth is 4. X to the fourth is -3. X to the third is 2. X squared is -7. X to the first is 9. And my constant term is -5. Okay, so go through and work out your synthetic division, just like we did the other day. Bring the first term down. It's all the same thing. Yeah.
So this is the first one that we did. Does that work for everyone?
Yes. Yeah, if it's asking you to find the value of the polynomial, you can just plug it in and work it out, and that works every time. But the remainder theorem says that if you divide by that number using synthetic division, that your remainder is also the same value. It just depends on which way you prefer. Do you prefer plugging things in and simplifying them out, or do you think synthetic division is easier? I'm not going to tell you which way you have to do it. Now, the directions usually will say use the remainder theorem, which means synthetic, but you can plug it in if you want to. Either way, it doesn't matter to me. So I'm going to bring that 4 down. I'm going to multiply 4 times 2. And then remember, we add. -3 plus 8 is 5. Then I multiply again. 2 times 5 is 10. I add, that gives me 12. 2 times 12 is 24. I add, that gives me, 17. Multiply, that is 34. 43, thank you. And then I multiply that again, that's going to give me 86. And then if I add -5 and 86, that gives me my remainder of 81, which was exactly the same thing that I got by plugging it in. So do you see how they both work the same? You can choose which way you want to do it. I don't care. You can either plug it in or you can do the synthetic division. Just remember the remainder is the answer. Is everybody ready to try one? Okay. New function. P of x is equal to -x to the third plus 2x squared minus 5x plus 2. And this time we're evaluating it when my polynomial, when x is -2. The only thing I would say about plugging it in, if you choose to do that method, be very careful with your signs. Those will throw you off. Again, you can either plug it in and work it out, or you can use the synthetic division, and your remainder will be your answer. Yeah. So take away that where it says answer. Just delete it out. There, that's our Plug in or synthetic? Okay, I'll do both. All right, so if we plug it in, again, this is a negative, so you got to be very careful too with this. I'm going to go through and take care of my exponents first. That negative on the outside stays. If I take -2 and multiply it 3 times, that gives me a -8. If I take -2 and square it, that gives me a +4. I'm going to leave everything else the same for now. A -8 turns positive, right? And then 2 times 4 is 8. What's -5 times -2? +10. And then if I add all that together, I get 28. However, if I do my synthetic, my -2 goes in the box. The coefficient of my x to the third is -1. The coefficient of my x squared is 2. X is -5. Constant is 2. Bring down that first term. We multiply, we add, we multiply, we add, we multiply, we add, and that remainder is the same. So again, it doesn't matter which way you do it. Is everybody good? Okay. Let's do one more of those before we move on to the factor theorem. This time my function, my polynomial is 2x to the third minus 3x squared plus 6x minus 3. And we are going to evaluate that for x being 3. That's why it's called the remainder theorem. You can plug it in or you can do synthetic division. It's fine. Unless you decide to divide it. All right, I'm going to do synthetic division this time just because I think it's easier that way. The 3 goes in my box. The coefficient of my 2x to the third, or my x to the third is 2. X squared is -3. X is 6. And my constant is -3. First term comes down. We multiply. We add. We multiply. We add. We multiply. And what do we get? 42. Does everybody agree with that? Okay. So again, when you're finding the value of a polynomial, you can either plug it in and simplify it out, or use that number in your synthetic division, and your answer is your remainder. So the next one is the factor theorem. We're going to be asked if any numbers are either factors or solutions or roots of our polynomial. Okay, this has to do with your remainder as well. If something is a factor, that means it goes in evenly, right? So if it is going to be a factor or it is going to be a zero, what would our remainder have to be if it goes in evenly? 0, okay? So that's what the factor theorem says. I'll give you just a minute to write that down. That -2, and we're going to put that in our box for our synthetic division. Now, you could also plug this in too if you prefer plugging things in, but I just prefer synthetic division because it's easier and faster. Then it is going to be a 1x to the third minus 2x squared minus 5x plus 6. So we're going to go through with our synthetic division, bring the first term down. We multiply, we add, we multiply, we add, we multiply, we add. So would this one be a factor or a 0? Okay, is my remainder 0? Yes. So would -2 be a factor of this polynomial? Yes. Okay. All we're looking at is the remainder. If that is not 0, your answer is no. If that is 0, your answer is yes. That's all we're answering is yes or no here on these questions. Is it a factor? Is it a 0? That means, is it a solution to this polynomial? Does everybody understand what I'm saying? Okay. Try those two. Last two. Again, your answer is either yes or no. If your remainder is the numerical value of 0, then the answer is yes. If your remainder is not 0, the answer is no. Be careful with 6 when you set up your synthetic division. We're missing some places, aren't we? So you need to put in some zeros. Again, be very careful with 6. We have an x to the 4th. We do not have an x to the 3rd. We have an x squared, but we do not have an x as well. So you're going to have to fill in a couple of zeros there. What do you guys think for 5? Yes or no? Yes. All right, and then again with 6, we have 1x to the 4th. We don't have x to the 3rd. Negative 13x squared. No x's. And then 36. And what about 6? Yes or no? Yes. Okay. Again, if your remainder is anything other than 0, the answer is no. Is everybody okay with those two? Told you it wasn't hard.